couple of systems that we looked at using solving using substitution. We had equations that were already set up with a variable isolated, in other words, a y equals something. But that's not always the case. And sometimes we have to solve for one of the variables and then substitute. And so here we have a system, 4x plus 5y equals 11, and then I've got y minus 3x equals negative 13. And so I don't already have one of the equations with one of the variables isolated. But as I look at these two equations, I can isolate the y pretty easily in that equation right there. And then once I do, I can substitute. So I can take this y minus 3x equals negative 13 and add 3x to both sides. And when I do, I'm going to be left with y equals 3x minus 13. And now I can substitute this 3x minus 13 in for y in this top equation. So let's work on that and then solve for x. So I got 4x plus 5 times 3x minus 13 equals 11. Let's distribute the 5 to the 3x minus 13. So I've got 4x plus 15x. Let's see, 5 times negative 13, negative 65. Yeah, 5 times 3 is 15, carry 1, 5 times 65 equals 11. We can combine the 4x and the 15x into 19x, and then we add 65 to both sides of the equation, and when we do, we're going to have 11 plus 65, which is going to be 76. So now we got 19x into 76. Maybe I'll just grab a calculator on that. I think it's going to be 4, but we're going to find out. Yeah, 4. So x is equal to 4. Now, with x equaling, if we think x is equal to 4, I'm going to substitute this x into this second equation, 4 for x, excuse me, into this second equation and solve for y. So let's see, I got y minus 3 times 4 equals negative 13. Negative 3 times 4 is negative 12, so I got y equals, y minus 12 equals negative 13. And let's add 12 to both sides of this, and when we do, we got y equals negative 1. So it looks like my solution is 4, negative 1. X is 4, y is negative 1. And let's go back to that 4x plus 5y equals 11, and let's substitute in 4 for x and negative 1 for y and see if we get a true statement. So we're checking our work now. So I got 4 times 4 plus 5 times negative 1 equaling 11. 4 times 4 is 16. 5 times negative 1 is negative 5. And 16 minus 5 is in fact 11. And so 11 equals 11. And so 4, negative 1 is a solution for our system. All right, let's look at one more where we're having to solve and then substitute. Okay, so this time I got x minus 3y equals negative 9, 5x minus 2y equals 7. My easiest one to isolate a variable is this top equation. I can go ahead and add the 3y to both sides, and then I've got x equals 3y minus 9. Now we can substitute this 3y minus 9 for x into the second equation. So then I'd have 5 times 3y minus 9 minus 2y equals 7, and we're going to solve for y. So 3 times 5 times 3y is 15y. 5 times negative 9 is negative 45 minus 2y equals 7. So I can combine the two like terms. So 15y minus 2y is going to be 13y minus 45 equals 7. And we can add 45 to both sides. So 13y equals, let's see, 45 and 7 is 52. And then divide by 13. So y is equal to, I believe, 4. 4 times 3 is 12. Carry 1. 4 times 1 plus 1, 52. Yeah, so y is equal to 4. Now that we've got that, I'm going to go back to that first equation, this equation, and substitute 4 for y and solve for x. So we got x minus 3 times 4 equals negative 9. And negative 3 times 4 is negative 12 equals negative 9. Add 12 to both sides, and x is equal to negative 9 plus 12 is going to be 3. So we think our solution then is x is 3, y is 4. And let's check our work by substituting in 3 for x and 4 for y into that second equation. So then I've got 5 times 3 minus 2 times 4, and hopefully that's going to equal negative 9. No, 7. It equals 7. I don't know where I got the negative 9. Oh, right below it equals 7. All right, 5 times 3 is 15. Negative 2 times 8 is negative 8. That's equal to 7. 15 minus 8 is 7. 7, in fact, does equal 7, and our solution is good. Solving and then substituting to solve a system of equations.